Welcome to episode 3 of the program, the show where we teach you how to write programs. And this is our third week in this, and we haven't even started a language yet, although next week is the big week. We start Python next week. So these first 3 episodes are designed to just teach you the basics under the covers of programming, because I have this strong belief that if you learn how to program and understand what it's doing beneath the covers, you can learn any programming language very quickly and without much pain at all. We are part of the TechZen TV network and also now part of the Alexa TV network. This Alexa TV is our distribution partner for the whole TechZen TV network now. So you can watch us live, and when you do, you're going to watch us on the Alexa TV network. But you can, all of our stuff's on TechZen TV too. They're just our partner for distribution. And if you are watching this on YouTube, I definitely ask you go out to TechZen TV and hit the subscribe button so that you get regular updates. And also it helps us keep our viewer counts and everything kind of accurately. So it also helps us get found, because the more subscribers you get, the higher you come into other searches. So it helps us a lot. And if you're getting us on iTunes, if you can go out to iTunes and click on the rating box and give us a rating, that's helpful as well. And iTunes is a big thing, and you're hidden, and you can't find yourself very easy unless you are getting ratings. So that it definitely helps us get found. And as I said, we're going to start Python next week. This week's kind of a little bit of a recap of the last 2 weeks, and we're going to talk a little bit about some object-oriented stuff, and compiled versus interpreted languages as well, and what that means. So that our first language we're going to get is not compiled; it is interpreted, which is Python. And the reason we're doing Python is it's very popular. It's fairly easy to learn. I will say it's a little bit different than the most of the languages. Like if you compare PHP and JavaScript and all them, they all have some very similar things. And this Python's just a little bit different. So, but it's not hard. It's just a little bit different. And yeah, again, if you understand the concepts underneath what's going on in the covers, you're not going to have any problem switching from language to language. Okay, so last week we covered functions, we covered loops, conditional statements like if then else, case statements, and for next loops, and while loops, and do whiles, and do untils, and all that stuff. So if you didn't watch that show and you want to learn, you can go back and watch episode 2 of this show. It is on YouTube and on the TechZen TV website, where all of our shows and all of our show notes are located. See if that helps any. All right. And if you're on Twitter, you can you can also follow us at TechZen TV. You can get regular updates on Twitter all the time as far as what's coming out. And if you haven't been to the TechZen TV website, it's tech-zen.tv. We got tons of other shows that you may like. And I mentioned last week about the Let's Make It show. If you're really into programming and you want to learn it, the Let's Make It show is probably what you want to check out, because we do a lot of programming and we make some very cool things using Arduinos and Raspberry Pis. And that may be expanding very soon as well to different things, but it's all a lot of programming, and it's awesome. We do Python on the Raspberry Pi, we do C on the Arduinos. So yeah, it's all fun. If you want to learn programming, go check out that show as well. Again, techzen.tv. You can also go to letsmakeit.tv as well. And this show is released every week on Wednesdays. Now, because of its format where we have different people doing different languages and they're kind of working on their own, it's all done pre-recorded, so we don't really have a live time. We just release it on Wednesdays. And that's just because it's consistent that way. So if you are looking for a live or come to the chat room with like other shows, sorry, we don't have it for this show. However, we do encourage you to email us at the program at TechZen TV, and we will get back with you. We're not too slow at it, but we are busy. So, and depending on the language, you may take that person a little bit longer to get back to as well. So we'll make sure we get forwarded to the person who did the actual show that you're talking about. All right. So this week, again, we're just going to recap a little bit what we've done the last couple of weeks, talk a little bit about object-oriented programming, which is we're going to start learning here next week, and talk a little bit about compiled versus interpreted, what the difference is, things like that. So the first thing I want to talk about is object-oriented. So I'm trying to think of the best way to describe an object-oriented thing. I think about this all day. So think of an object, and I'm going to take this PC board as an example. So this PC board is the object, and it has properties about it. So You're not holding it, but I am. But you can tell that it's white. So one of its properties would be color, and that'd be another property is it's made of metal. Well, mostly made of metal. Lots of copper. So its materials would be copper. It's square, so its shape would be square. So think of all the different properties that you can have for this particular card. So this is the object, and think of the properties that you can have to it. So that's basically what properties are for an object. So now there's things you can do to this card. I can turn the card over. So the function that I want to do is turn the card over. All right, turn the card over. So there's the function. There can be a function that says drop. There's drop. So you can see there are actions you can take or functions you can take on here as well. So there's also properties that can see how many holes. I don't know how many holes there really are, and you probably can't see them on the camera very well, but there are a bunch of holes for chips on this board. So that's an object. Now in programming, obviously it's not a board, but it could be, if you're talking about object-oriented from a point of view that it's stored, you may want to store information about the object in a database, for example. So I may be storing parts, and the object itself is this card, and then I have certain properties about the card. And then you have functions, order more, make more, whatever functions you wanted to create around that object. So that's basically what object-oriented programming is. And it sounds so simple the way I'm putting it, but that's what it is. So in programming, you define an object, and it can be an object for something programmatically. It could be something physical, or it could be a database entry or a product or something that you're working on. An example would be a customer. A customer, if you're looking at a customer record in your program, the customer is the object. So what is it about the customer? Well, property is a name, property is an email address, property is an address, property is a phone number. And then you have functions. You could have functions call, you could have functions email, functions delete, functions new, functions rename. I mean, all these different functions that you have for the object. So think about it from that point of view. So what object-oriented programming does is it creates something called a class, and the class is the object description. So in that class, you define the properties. In that class, you define the functions as well. So if you look at it in programming, you would have function or the class of customer, and inside there, you would have functions for email, functions for delete, functions for call, functions for upgrade, something like that, whatever functions you would have. And then you also define their name and everything else. So when you work with the object, you could say customer.name equals, or customer.call. And then that would call the customer. Customer.email would email the customer. And that customer object has all the information. So when you go to email, the email functions inside that class. It already has access to all the data for the customer, so it doesn't need to do anything else. It has it all right there. It's part of the class. You could do customer lookup, like lookup for sales orders. So you do customer lookup, and it would go in and populate an array. It'd be customer.orders that would show all the orders. So that's basically what an object-oriented programming is. It's instead of having all these random variables all over the place, where if you're doing it without a class, you would have customer_name, customer_phone number, customer_address. You have to create all these variables, and you have to populate them for each time. Now, the thing about using object-oriented is you can have more than one customer. So let's say you have 3 customers and you're moving orders around in them. You can have customer1.name, customer2.name, customer3.name, all independent of each other. You can do customer3.email and customer1.email, and it'd be separate addresses. Where if you're using just global variables like customer_email, you only have one at a time. So it's another way of doing it. I think it's a much cleaner way of doing programming, and it takes a little bit to get your head wrapped around occasionally. And I sometimes will sit down and I'll redo a class a couple of times before I figure out the exact class structure or classes structure that I want to use for a program, because I've got to really think about it. But if you think about it from the point of view that it's all reusable as well, it makes it very easy to understand. Plus, when you're doing something with the customer, you know where to go. You go to that class file, and there's all your stuff. So that's object-oriented programming. So there's another side of object-oriented programming, and that was the classes part of object-oriented programming. When you get into GUI type interfaces, like the graphical user interfaces, an object is going to be a button. So you have a button on the screen you put there. That button has values. It has a name, a title, or text. It may say text, like what the button says on it. And it says, what kind of button is it? Is it a push button? Is it a toggle button? So those different variables. And then it has functions you can call, but it also has what they call events. So this new object you created, this button object, has an event it's called push, or push button. Notice I won't say click. Click's probably the most common one. So you say inside the class, if button click, then you do this code. So we talked about this conditional statement before. In this case, you don't need to do the conditional statement because it's going to call that function in that class whenever that action happens. So when we get into doing JavaScript with like Sencha or something like that, you're going to see this a lot because they have the whole concept of events because they're doing graphical things. So when somebody right clicks on something or clicks on something or drags it and moves it or resizes it, all these events get fired off. And if you define in that class the function you want to happen, it will call that class function inside that object. So the object in this case is some kind of screen thing. It could be anything on the screen. It can be somewhere you put your text. So anytime you type a character in a field, it's going to call this function. And in that function, you can say, I want to uppercase everything, or I want to check to make sure it's valid information. So you check the value. You can do whatever you want every time that key is pressed in that field. Or when someone right clicks on it, I want to intercept the right click and do something different. That's all happening in this object because the object has the functions in it to be able to handle the events that are coming from that object. So I know that's considered object-oriented programming. I tend to call that event-oriented programming because yes, it is a class and it is an object, but you're programming based on events because you have certain events happening when certain things happen on the screen. And there is this term called MVC, Model View Controller, and we're going to talk about that and much more in the Sencha area because their whole new structure is based on this Model View Controller. And the whole thing is about Model View Controller is view is what we're talking about, the buttons. So in the view, you have these events, and then in the controller, you can write some of your logic or business logic, some people call it, and call it from inside the event. So you're going to put, so you have some kind of logic you use a lot and in multiple places. Why code that into the button directly when somebody presses the button? Why not call the controller to do the work? And you can call it from multiple objects as well, multiple different pages, objects, things like that. So that's considered the controller. And then the model is just a data structure underneath of it. But we'll get into that in other languages. I think it's probably going to be the Sencha language when we start getting into Model View Controller. If we could do that, and before that or C#, we may talk about it as well because they use an MVC architecture as well. So that's coming up, but don't worry about that detail. The main thing I want you to understand is the object itself has value and functions, and in the event that you're using an event-oriented language, what I consider event-oriented, it's still object-oriented, but it's based on events. You will have in the object itself an event controller, and you can attach things to that object. So think of the object, a physical thing, be a button on the screen, a customer record, whatever, and its values and its functions you want it to happen on it. All right, so that's a real high-level object-oriented, and I will say that different languages handle object-oriented a little bit differently. The concepts are the same, but the way they handle it's just a little bit different, and they're not radically different. It's just somehow how they do specifically when they get an MVC architecture, they handle things a little bit different. So we'll talk about that in those languages as well. But that's just, remember, an object holds values and it has functions. Okay, so let's get to compiled versus interpreted. So compiled versus interpreted. Basically, the big difference is when you compile something, it takes this English thing you created, basically, I'm going to call it English because you can read it, and converts it to machine code, which is something that if you reverse it and put it into assembler, you can figure out what it's doing, but it's very difficult even in assembler, which is above machine code. So we're not going to get into machine code other than say that a machine code is basically, as mentioned in the very first episode, a function, which is typically a byte or a word, depending on what operating system or what hardware you're running on, and then an address and maybe a register ID. So you basically call a function in a memory address and maybe two memory addresses if you move things around, and that's how the function works. So it's running, it basically is a few bytes that are doing all this really big, bunch of functions and everything. So to get to that though, you have to take what you wrote in your if statement. Your if statement may end up being 100 lines of assembler because it has to go through all this additional checks that's converting things to zeros and ones, and that's compiled. Basically, if you compile your program, it does all the thinking how to get it to machine code right then, and then it's ready to go, just ready to execute. Where when you're talking interpreted, what has to happen is when it runs, is take your English every time it runs and convert it to something that will run on machine code. Now, typically an interpreter is something that's written in machine code, or it's running in machine code, and it takes your stuff and converts it to a pseudo language, basically a lower level language that's not machine code, but something that the machine code can understand. So it's kind of an intermediate. So a compiler takes your English stuff, puts it into machine code, so the machine can run without any need for any help. When you run something that's interpreted, the interpreter is compiled to machine code, but it takes what you've written in English and executes it based on pre-written programs that are converted to machine code. So the computer itself isn't going to run your native code. It's going to run an interpreter, which runs your native code. So the disadvantage to running an interpreter is every time you run it, it has to be converted or interpreted. Where if you compile something in machine code, it just pops it into memory and runs it. So it's a little bit slower for interpreter stuff. Now, with computers today, as fast as they are, most people don't even know the difference. But if you're talking about a high-performance program and a lot of input-output, you want to look at probably something that's compiled. So, and again, it depends on the language. And some languages actually have, I've seen this, I can't say I've actually tested them yet, have a pseudo-compiler, which can kind of take interpreted languages down to a binary. But I think, from my understanding of how they work, is they take the same interpreter or a variation of the same interpreter and take your code down to pre-interpreted or to post-interpreted, so that when it runs it doesn't have to go through the interpretation process. It just runs it. It's like a hybrid between the interpreter and the binary code. So haven't used any of them, but I think during this next couple of weeks or next couple of shows, we may be talking about that a little bit. In fact, the people that are going to do some of the other shows, I may ask them to talk about them a little bit and give some input on how good they are or how bad they are in either case. So, all right, some of the languages we're talking about next week. We're starting Python. Week number 1 of Python is next week. And after that, we have in the queue Perl and PHP and Sencha. Those are the 3 that I know for sure. I'm trying to find somebody who can do the C# for me. And I don't really want to do it myself, but if I have to, I will. So we won't run out of content. We get tons of languages coming up. So go through it, because we have very specific languages as well that we want to get to. C# being one of them, because it's kind of Microsoft only. PHP is kind of generic. Python's kind of generic. Perl's kind of generic. And Sencha's kind of generic. But when you get into C#, you were talking about a Windows machine. And we talked about doing Objective-C, which is writing code basically for iOS or for Mac. Again, very specific. But we're looking at for our languages as well. We've had requests to do Ruby. I don't know anybody that does Ruby, so we're trying to figure out if I can find somebody that does Ruby or Ruby on Rails, or a combination of the two, and put something together for that. So that's all coming up. But next week, we're definitely starting Python. Week number 1 of Python is next week. So if you want to learn Python, this is the place to be next Wednesday. We release a show every Wednesday. It is pre-recorded. So we do up to 12 weeks of recording at a time for a particular one, and we stick it in a queue and we release it. However, you at any time can send us an email to the program at TechZenTV if it's questions, complaints, comments, whatever. We love everything. We get everything. We love it all. We just love to get feedback from people. So that's definitely the number one thing is feedback. But we do release it every Wednesday. If you want to watch us on YouTube, it's youtube.com/TechZenTV. All of our shows are there. You can subscribe on iTunes to the program or the whole channel or any other of our shows as well. All of our show notes for all of our shows are at tech-zen.tv. And when you get there, click on the shows link at the top, and you can pick the show that you're interested in and go to the episode you're interested in, and your show notes will be right there, ready to be read and consumed. All right, that is pretty much it for this week. Drop us a note on Twitter at TechZenTV. Next week is Python. We'll see you next Wednesday. For show notes for this show, contacts, and more, go to the TechZen.tv website, where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the TechZen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.